Welcome back to the Math Classroom. If you are new, kindly don't forget to subscribe, like, and share the video among your networks. And to my already subscribers, I say, Ayiko. Our lesson today is on integrating exponential functions. If I have an exponential function, how do I go about it? So let's say I have an exponential function, the integral e to the power f of x dx. Okay, so with exponential function, you realize that our exponential always has a function. E exponents a function. If it happens so, it says that if I have a function of this form and I want to integrate, it says what you have to do is you differentiate your exponential function. So first, differentiate f of x. So you have this. So you differentiate f of x, which is f prime of x. Then, you divide the results by the exponential function. So I have my 2 is going to be my exponential function f of x, then the result of the derivative, which is f prime of x, plus my constant c. Hooray! We are done. So if I have e to the power x dx, what is the function? The function here is f of x is equal to x. What is the derivative? F prime of x is going to be 1. So that if I want to find the integral of this, e to the power x is going to be the exponential function e to the power x divided by the derivative, which is f prime of x. And this is going to be e to the power x, because this is 1, plus my constant c, plus c here. So this becomes my result. Let's take another example. Let's say I have the integral 5 e exponent 5x dx. So how do I go about it? The function is f of x is 5x. What is the derivative of that? This is going to be 5. So my integral e to the power 5x dx is going to be the exponential function e to the power 5x divided by the derivative at the exponent, which is 5, plus my constant c. So these are definite integral. Now let's look at some other unique exponential functions. So other unique exponential functions I have. Let's look at how that is. So I have the exponential function, a very unique one, of course. You are given find the integral a to the power x dx. So you realize that this is a very unique one as well, because you have some exponential involved. But the question is, let's look at the base here. You ask yourself, is it e? So we want to convert this to an exponential what function. That is what? A to the power x. We want to write a to the power x in terms of what? E to the power what? Something. Okay. So from here, you realize that I want to write this exponential form of this. So I can write e to the power x as what? Exponential ln of what? A to the power what? X. Ln of a to the power what? X. Okay. And this is the same as writing e. You remember your indices logarithm. This is the same as e to the power what? X ln what? A. Okay. So why? Because you realize that e to the power ln is what? This is going to give us that. If I take exponential of to the power ln of this, at the end, this is what I get. So it means that this is going to be equal to what? This. Okay. So then, from here, I can then write this as the integral e to the power x ln a dx. If I differentiate this function, so now my function f of x, it's equal to what? X ln what? A. So that if I take the derivative of this with respect to x, what do I get? Ln what? A. Okay. So from here, what do you have? So from here, my integral e to the power x ln a dx is going to be e to the power this, which is what? A to the power x, because this whole thing is what? A to the power what? X, divided by ln a plus my constant what? C. Maybe an example will do. So let's say I have the integral a, it's any real number. So 5 to the power x dx. It says it is what? A. So 5 to the power x divided by what? Ln 5 plus a constant word c. So this is a property you should know. So the property is, if I have the integral a to the power x dx, so this is a to the power x dx, it's equal to a to the power x divided by ln of a plus c. A very unique property you should bear in mind for an integral. Okay. Then you could look at other properties of integral when it comes to trig functions. Then you can talk about the hyperbolic functions and the standard integrals as well. I kindly urge you to read more on that. don't forget to subscribe.